So in the last lecture, we figured out how to extract the data for a single post from Craigslist. We reverse engineered the page structure. Now we're going to do this more systematically. We did it for one, let's do it for all 120 posts that are on that page. So this will also give us more practice of scraping web pages and parsing text. And we'll also introduce the concept of an exception and how to handle the exception or an error in graceful terms. And then we'll do some more plotting with pandas at the end. So let's carry on with our Craigslist example. So we already figured out how to extract this information from a single post. Now let's put all 120 into a data frame. So Panda's data frame constructor is pretty smart. It can create data frames from lots of different structures. But one of the easiest ways is to create a list of dictionaries and then tell pandas to convert that list of dictionaries into a data frame. We'll see what this means in practice in just a moment. But conceptually, each element of this list is going to be a post, and within that list element, we're going to have a dictionary of columns and the contents of that columns. So let's first of all recreate the list of posts as we had before. This is the same code as we saw in the previous lecture. The same listing that we saved to our hard drive. So rather than just doing it to one, let's loop over this list of posts and use the code that we just wrote to extract every element that we care about, like the number of square feet, like the number of bedrooms, and store this in a dictionary. And then create a list of these dictionaries that we can turn into a data frame. And we're going to be assigning some temporary variables. So what does this mean in practice? Well, we import pandas, and then we're going to start with this empty list. And then we're going to append to this list each time we go through the loop. So let's loop over the posts. We're going to call each individual posting. This is the kind of one-liner with the description, the number of bedrooms, and so on. We're going to call it posts as a loop variable. And this is everything that we had before. I just indented it. For these individual posts, we're going to find what's in the title string. We're going to get the text. We're going to get the URL. The more complicated way to get the neighborhood. And then we're going to get the price, the number of bedrooms, and square feet. But just rather than printing them, I'm storing these in these temporary variables called neighborhood, price, bedrooms, square feet, and so on. And then let's put them in a dictionary. For simplicity, we'll give the keys the same names as our variables. So we're going to have a title key, which is going to have whatever was in this title variable, which is basically this. The URL key is going to be whatever is in the URL variable. So it's going to be this, and so on. And then this dictionary, once we've created it, let's append it to our list, which starts off empty, but by the time we finish this loop, we're going to have 120 of these. And then we're going to create this into a data frame. Right, so this is going to be amazing. Watch this. Oh, okay, we got an error. So if you see an error, the number one thing to do is don't throw your laptop against the wall, don't run screaming, don't smash your monitor. It's fine. We're going to get errors all the time. This is just part of the price of doing business with unfamiliar data sets. But let's figure out how we can manage this error. Well, here this is somewhat helpful. It's telling us what line of code the error occurred in. It's trying to get the text out. And it's also telling us that a none-type object, so basically a blank object, doesn't have this attribute called text. So we're trying to extract this text from this object, but it just doesn't exist because it's an empty object. So let's see why this is happening. So again, it looks like we couldn't get our BR variable because there wasn't any text. So let's back up, see what this object looks like before we try and get the text. So this was the line that Python told us the error occurred at. So I've taken this just without the text at the end. If I add text, I'll probably get the same error. Yeah. But if I just print it, I get no output. I get nothing. Why? This is because it is a none-type object. And if we do type, we can confirm that for ourselves. It's a none-type object. So we can't ask to get the text when nothing exists. So let's try and be more robust to these types of errors. In this case, it was just caused by some missing data on the Craigslist webpage. There wasn't any number of bedrooms in this listing. So one way to do this is this try except syntax. So basically we try a block of code, and if something goes wrong, we execute the alternative code under except. So here I just indented everything, and I put it under this try this try syntax. So it's going to run through this code, but if I get an error anywhere in this block, I'm going to run this line. In this case, I'm just going to append an empty dictionary to our list of posts. So let's see if this works. So now we get some result. But notice we have a lot of empty rows. So all these rows were something where we got an error here in this block when we were doing try, and so we ran this line instead. So the try except syntax, as you see here, is useful. It makes our code run, but it's really blunt because we lose a lot of information. And we lose all the data for this posting, not just the number of bedrooms. So one alternative, which is a little more nuanced, rather than use try except, is to explicitly check for missing data at each step. So let's start off the same way as before. What I did here is rather than assign the result of this text to the br variable, I assigned it to something I'm going to call br temp. And I'm going to check explicitly to see if this is none. And if this is none, then I'm just going to call our br variable none. But if it's not none, we can do exactly what we did before. We can extract the text of this object. So br was missing in many of the postings. It also turns out that the square footage information is also missing. So we can do it the same way, but just a little more compact. So we create this temporary variable, exactly the same as we did for br here, with the information that's in the post square feet class. But if it doesn't, Beautiful Soup doesn't find anything, then I'll condense this into a one-liner. It's going to say that the square foot is none if my temporary variable is none. Otherwise, I'm going to take the text out of it. So it's a more compact way of writing these 4 lines here. And then let's proceed as before, put it in a dictionary, create a list of dictionaries, and then put it in a data frame. So great. So we have some missing data here for bedrooms and square feet, where she got the price and the neighborhood and everything else that we wanted from Craigslist here. So now let's plot this. Maybe we want to see what the distribution of rental prices of rents are. And a box plot would be a good choice here. It's built into pandas. We can use the box plot function and tell it to plot the price column. But oh dear, we get an error. Here this is quite a lengthy error, and it doesn't look nearly as helpful. Actually, until the end, where it says the box plot method requires numerical columns, so it doesn't have anything to plot. So we get an empty graphic. Well, the error message is only somewhat helpful, so let's look at the data for this column. Okay, and we see the problem right away. We actually have a string. Our data type is object, and we actually have these $ and commas in the string variable. So let's convert this to a number. It's going to be a 3-stage process. We want to remove the $. So in practice, we're going to replace each $sign here with an empty string. We're going to do the same for the comma. And then we're going to convert the data type to a float using as type that we've seen before for integer. Here we're just going to do as type float. So we operationalize this in a string. So df price are string functions. We're going to replace what's the $sign with an empty string. Then with what's returned from this, we're going to do another string replace operation. We could do this as 3 separate lines, but it's more compact to chain these together. So now we're going to replace the comma with the empty string, and then finally we're going to convert everything to float, and we're going to store the result in this new column called price numeric. So we get a warning, but we actually, let's see, yeah, we do actually get a new price numeric field that's the same as price, just without the dollar signs and commas. So I'll leave this for you as an exercise to convert the SF and BR fields to a numeric in exactly the same way. So pause the video, do this for yourself. How did I do this? Well, the same function, the same approach. I created, I'll just overwrite the column in this instance rather than create a new one. And I'll take what's in SF. I use the string function to replace it, and I'll replace what's ft2 with an empty string, convert it to float. And something similar for bedrooms, and let's look and see what that gives. Great, so we have some missing data, but we have numeric values, and our data type will be float. So let's do our box plot. Great, and now we get a nice box plot. We see the distribution of rents. So most in this $2,000 to $3,200,000 range. We also have some really expensive apartments, $6,000 and close to it. Boxplot has a nice function, a nice argument called by, which breaks it out by a second value. So we can use by neighborhood to do a different boxplot for each neighborhood. But there's a problem here that we have too many neighborhoods. So we have lots of box plots, but a lot of these only look like they have one observation. So what's the problem? It seems that we just have too many neighborhoods. Well, let's look at this. In this instance, the unique function of pandas is useful. So we can ask it to return all the unique values of the neighborhood column. Okay, and now we see what the problem is. So some we might expect to have lots of observations, like West Hollywood, Santa Monica, West Los Angeles. But I'd be surprised if we get more than one listing where the realtor or the landlord goes crazy with lots of stars, or says the neighborhood is moments to Ventura Boulevard. So it's really messy data. So we'd have to do some pretty extensive cleaning if we want to convert these into lots of neighborhoods. So let's hold off on neighborhood relationships for now. But we could look at the relationship between some of these variables. And so, for example, we could do a plot of the square footage against the price using a scatter plot. So here, not surprisingly, we show a relationship that the larger the square footage of the apartment, the higher the price. So we've created a data frame that extracts all the posts on this first page of Craigslist. We've really only scratched the surface. For example, we only have one page of listings, the first 120. It would be useful to get data from the subsequent pages as well. We found out our neighborhood field is really messy and dirty, so it's hard to do any neighborhood-specific plots or any mapping. We don't know anything about parking, and we don't have the geographic coordinates. But let's stop here and save that for future work. So the takeaways from this last lecture in this module are that the less structured a web page is, the more detective work you're going to have to do, and the more trial and error, the more errors you're going to come across, and then you're going to have to go back and add that possibility or try except perhaps into your code. So some are going to have a consistent format and helpful class codes and HTML tags, some won't. And your code is going to need to be robust to missing fields. If you're looking at it on the screen, then just because there's no bedrooms information, that's not a big deal. Your eye can process that. Python, you need to tell it explicitly how to handle these situations. And as with APIs, this is even more important for web scraping. Be nice. Don't overload the web server. Don't give them reason to think that you're a hacker or some sort of bot, since you may need to slow the pace of your requests down so that you don't overload the server, and then they're going to kick you off and no one's going to be happy.